Exactly. So I'm going to come up here. What if I had I to the fifth power? So this is where we ended. This is where I'm going to start, just to review. So I, literally, the definition of I is the square root of -1. So hopefully we remember this. You have to know this. I do not give this to you on your test. Exactly. As Dylan said, there is a pattern. So I to the first power is I. I to the second power. Literally, you're taking I times I. That's what it means to be second power. So if I have square root of -1 times square root -1, this is the same thing as square root -1 squared. The square and the square root cancel out. I'm left with -1. Okay. Are we okay? Like today's a fresh day, right? I squared. We understand I squared is -1. So now if I have I to the third power, just
I have a question.
yes.
Do you remember back then when I asked you why is this not right and the other one
Yes.
is right? Do you have the answer?
Yes, you have to
also?
multiply first. You can't just turn each one into an I. Do you
Okay,
understand what I'm
and
saying? So it was
also-
root -12 times root -2.
Uh-huh.
You have to multiply them. And only at the end, when you only have one radical, do you deal with the I.
And also, when you had root negative and then root negative and you multiply it made it into a positive.
Yes.
This doesn't do that because it's a
Because I have the same thing and it's being squared.
same thing for square. Okay.
Yeah.
If it wasn't the same thing, if that was a 2, it would have just become positive 2 because it's like negative.
Yeah, let's see. Squared. Because it's the same thing, so the square root goes away because it's squared. I don't think that answers your question. I think I see what your question is. All I'm trying to do is explain why I squared is equal to -1. Because this is a known fact, and this is something you have to know. Let me think why that's the case.
I asked the big question.
Yeah, I'm sure I'm sure if you read your textbook, it'll tell you why. Yeah. I cubed. So, I cubed is the same thing as I times I times I. This right here, I squared, we know it's the same thing as -1. So, I'm taking -1 times I, so that's just going to be -I. So, we went over this yesterday, but just a nice little review. Well, we're not through the pattern. It's kind of like hopscotch if you've only gone one block. You don't see the pattern yet because we haven't done it yet. I to the fourth power. I times I times I times I. Okay. I know I squared is -1. I times I is -1. -1 times -1 is going to be +1. We are now through one loop, one cycle. Let's go to I to the fifth power.
It's the same cycle.
What? Yes. But each row is one cycle. So going to the next row will be the pattern. So I to the fifth. I times I times I times I. Oops, I forgot. Times I. This is equal to -1. This is equal to -1. And then times I. What I'm doing up here is like rewriting them in terms of I squared. -1 times -1 is 1. 1 times I is just going to be I. Well, I squared is -1. That's what we went over here. I squared is -1. So if I see two i's being multiplied, it's the same thing as just saying -1.
You're making this sound a lot more complicated than it is.
Thank you. I appreciate your input. So I to the sixth power. Like I'm hoping you see a pattern emerging. So I multiply I by itself 6 times. -1 times -1 times -1. So it's going to be -1.
Yeah, it is. -1 times -1 times -1. I know, but they're all ones. That's the kind of thing I was trying to get at.
I to the seventh.
So the
4,
pattern is
5,
I,
6,
negative
7.
I, negative
1,
one,
negative I,
negative I,
1. I,
You just write it out.
-1, negative I, 1.
No, it's not right.
Yeah, but like if you give us a number like
So
randomly, how do we know if it's a negative?
right, so that's the next thing I'm going to go over. I'm going to explain how we use the pattern. And this is why I'm going over it again. So this whole thing right here is -1 times I, so that's just going to be -I. Okay, so we see there's a pattern. This is 1. I to the 8th is 1. I to the 9, I to the 10, negative 1. I to 11th, negative I to the 12th, 1. So, let's look at the exponents. Notice all the ones on the very right column. If I take the exponent and divide by 4, what's the remainder? If I divide all the exponents by 4, what is the remainder? Huh? 4 divided by 4 is 1. How many remainder? 0. Because 4 goes evenly. Okay, what about if I take things in the second column? What is 7 divided by 4? 1 with 3 remainder.
Why do you do divide by 4?
Because there's a pattern. It's 4 different choices. It's either going to be I, negative 1, negative I, or 1. There's 4 different choices, 4 different numbers we could have. And what about things in the second column? If I take I to the 10th power, so 10 divided by 4, it goes, how many times does 4 go into 10 evenly? 2. And how many remainder? So 4 times 2 is 8. 8 plus what is 10? So 2. 2 remainder. And if I take something in the first column, 9, for example, 9 divided by 4. 4 can go into 9 2 times, and how many remainder? 1. So if you take, so I could give you any exponent, and depending on what the remainder is, you know which column it goes into. So if I example, let's do something hard. I to the 43rd power. You know exactly what that's going to be. So you take 43, divide by 4, and I want to know how many remainder it has. So I could do 43 divided by 4. So 4 goes into 4 once. 4, 0. 4 goes into 3 0 times, and that means a remainder of 3. Remainder of 3 means negative I is what it's going to be equal to.
Oh, so like the third one, whatever the remainder is.
Wait, why did you do 4 then?
But what if the remainder is more than 4?
It won't be, because there's only 4 choices. You're dividing by 4. If you have a remainder of 5, then you didn't put the right number at first. Let's do an example. Just a second. So if I do I to the 137.
Is it always 4?
Yes. You always look at, it's always going to be 4. Because how many different choices do we have? 4 choices. It'll either be I, negative 1, negative I, 1. Those are your 4 choices. And it goes in that order. So you have 1 remainder, first column, 2 remainder, 3 remainder, even. That's why we're dividing by 4. So if I take 137 and divide by 4, let's see, it doesn't go into that. 4 into 13, 3 times, so that's 12. So that's 4 goes into 17 4 times, 16. So guess what? Remainder 1. What? Long division. Remainder 1. So wait, first remainder, ooh, it's just going to be I. Ah, yes. Okay. Nice little review, and let's.
Wait, so are you gonna give us stuff like that? It's like I to the power and figure out which one it is?
Yep.
What about like the 137?
Yep. Because it's very doable. Because you guys know how to do long division, and the remainder literally tells you which one to go. I, negative 1, negative I, 1. And you're like, okay, 1 remainder, 2 remainder, 3 remainder, even. It just takes practice. Operations with complex numbers. So adding, subtracting, and multiplying. So all you have to remember for this is you only can combine like terms. So literally, you only can combine, add and subtract imaginary numbers together and real numbers together. Yep. Top of page 36. So I have to combine like terms. So notice 3 and 4 are both real numbers, and you're adding them. 3 plus 4 is 7. And then I'm looking at the imaginary numbers. 5i plus negative 3i is going to be plus 2i. And that's it. You're just combining. What? No, I just said find the following sum or difference. I did it. I combined them. Done. No. Nope. All right. Next one. 6 minus 5i minus 3 minus 2i. So the big one here is if you distribute the negative, you'll have 6 minus 5i minus 3 plus 2i. And now that I have them all in one line, I can just combine like terms. So 6 minus 3 is 3. And then negative 5i plus 2i is just going to be minus 3i.
Negative 5y
What? Negative 5i plus 2i?
plus negative.
Because it's minus a negative is adding a positive. Yeah, because minus a negative, same thing as adding a positive. Perfect. So that's adding and subtracting, right? Having a sum or a difference. Sum means add, difference means subtract. And you only combine like terms. So if something has an I in it, you only can combine it with other things that have an I in it. Now this is different than multiplying. So if I'm multiplying 3i times 2 minus 5i, we must, starts with a D, distribute. Okay, I'm going to distribute. 3i times 2i is going to be 6i. 3i times negative 5i is going to be negative 15 I squared. But wait, we know what I squared is. I squared's negative 1. So I have 6i minus 15 times negative 1 gives me 6i. What is negative 15 times negative 1?
15.
Plus 15. Okay, so I'm going to pause here for a moment. The hardest part, like you guys know how to distribute. We've been distributing since day 1 in this class. Understanding that I squared is negative 1, and then since negative 15 is being multiplied by I squared, you have to take negative 15 multiplied by negative 1. Okay. Now let's try B. So I'm looking at B and I have 2 binomials being multiplied. So normally when you have 2 binomials, you must FOIL. Oh my, see? You got it. You guys know what you're supposed to do. It just looks a little weird. That's it. We're going to FOIL. First, outer, inner, last. I'm just going to write that out. All right, first, 3 times 5, 15. Check. Outer, 5 times negative I, negative 5i. Inner, negative 2i times 3, negative 6i. And L last, negative 2i times negative I is going to be positive 2i squared. So, there's 2 things we have to do to simplify. First, I see in this middle, I have negative 5i and negative 6i. So I'll go to negative 11i. Okay. Wait, yeah? Just combining like terms. And then I have to deal with this guy, these 2 right here. So I know that 2i squared is the same thing as saying 2 times negative 1. I squared is negative 1. So what I have here is 15 minus 11i minus 2. So 15 minus 2, I'll have 13 minus 11i. Ah, that's close. It took 14 minutes, not 10. Yeah, that's it. So 15 minus 2 is 13. You only can add and subtract real numbers together and imaginaries together. What?
Isn't it negative 2?
Yes.
Starting with negative.
Yes, I squared is negative 1. This is I squared. And when I took negative 2i times negative I, negative 2i minus negative I is going to be a positive 2i squared. I squared is negative 1, so you're taking positive 2 times negative 1. So it's negative 2. Awesome. So, completing the square. Sorry, let me go back for a sec. Do we have questions about this page? It's the same like methods we've been doing, combining like terms, FOILing, distributing. It's just whack because we got imaginary terms, right? And when you have imaginary times imaginary, you get I squared, and that's just negative 1. Okay. So, completing the square. The square root property. For any real number n, if x squared equals n, then x equals plus or minus n. Okay, what the heck is this saying? If you have x squared equals 9, and you're trying to solve for x, you take the square root of both sides. And when you are taking the square root, right? So you're solving for x, you have x squared equals a number, and in order to solve for x, you have to put the square roots to get x by itself. You have to introduce the plus or minus. So this is a difference. If I say, oh, x equals square root 81, you say, oh yeah, that means x equals 9. When you have, like when you're computing, if the paper, the book, gives you the root and you're computing it, you just go with the positive root. But if I said x squared equals 81, you have to square root both sides to solve for x. That's when you include the plus or minus 9. The plus or minus in front of the root. So I put this on your MyJag for a while. Ashton, get off your computer. Follow along in the notes. I want the computer away. I don't want to see it. So, is it clear? It's very subtle, but is it clear when you include the plus or minus and when you just like leave it alone? Okay. What?
Is it only like problems with the square or
This is the first example of a lesson. So we have a whole lesson to do. I don't know if, are you asking if it gets harder? Yeah, man.
No,
this is the first example of the problem.
we're not doing like the other examples you said, like just x without the
Very
plus
few
minus.
times am I might give you something like that, but when I'm talking about the square root property, I'm trying to see what solutions I have. So notice, I didn't say a equals. This is not what I wrote. Right? I wrote a squared equals 25. So in order to solve for a, you have to square root both sides, and you see a equals plus or minus root 25. So this is plus or minus 5. That is the solution. So the big thing is knowing there's two solutions whenever you're taking a square root. Because there's two things that I could square that would satisfy this equation. If I plug in negative 5, okay, well negative 5 times negative 5 is positive 25. Okay, let's go ahead and let's solve the next one. B plus 4 squared equals 49. So how would I go about solving this one? First thing, square root, because I'm trying to get b by itself, so I square root, get rid of the square.
Turn it into 7.
So I have b plus 4 equals
Plus or minus.
plus or minus 7. Plus or minus 7. Since we are taking the square root, we're introducing the square root. I will, yeah. So I'll have to subtract 4 from both sides. So I have two different answers. I'll have b equals positive 7 minus 4, and I'll have b equals negative 7 minus 4. So this first one, positive 7 minus 4, I see b equals 3. Negative 7 minus 4, I see b equals 11. So there's two different numbers where I plug it in would give me 49. Sorry, yeah, negative 11. Thanks. Negative 11. So if I plug in to check, and I'm not going to do this every time, I just want to like appease you to show you that this is true. So this part in pink is showing you like, hey, guess what? When I plug in b equals 3, works out. If I plug in b equals negative 11, let's see, negative 11 plus 4 squared equals 49. So this is negative 7 squared equals 49. Negative 7 squared is 49. Okay, so that one works as well. So showing you our answers work, right? We're just plugging in, proving that this worked. No, you don't have to check, but this first one, I'm just writing to prove that it works. Okay, so what about part C? If I try to factor it, what adds to 11 multiplies to 36?
12.
What adds to 12 multiplies to 36?
8 and 4.
Adds to 12 multiply 36. So wait, you're saying 6 and 6?
6 and 4.
6 and 6 add So this means I have x plus 6 and x plus 6 equals 0.
We also do like the 12 parentheses x to the second plus x.
12 parentheses. Wait, I'm sorry, what?
Sorry, 12 parentheses x to the second, yes, plus x plus 3. Like after that,
So there's no 12 right here. This would literally be x squared over 12.
so they all
They all have to have a common denominator, and I don't have that. Okay, so I could, instead of saying x plus 6 times x plus 6 equals 0, I could write it as x plus 6 squared equals 0. Ah, because it's the same thing, right? It's being multiplied. If you have an x times an x, you could instead write it as x squared. If I have x plus 6 times x plus 6, I can write it as x plus 6 squared. Nope, because we have to solve. We have to actually find what x is equal to. So let's go through the steps. First thing I must do is
wouldn't it be
Square
easier to just
root.
keep it in the first form if we have to solve it?
So the idea behind this example is showing you the square root property and connecting the perfect square trinomial to the square root property. So showing you that the perfect square trinomial, which this is, gives you two binomials which are the exact same thing. So my hope is by some magic voodoo or nonsense, I'm going to show you how perfect square trinomial helps you, is connected to vertex form. We use the square root property as well. I mean, that's my goal. I don't know if I'm going to be able to achieve it
I just
today.
I did x plus 6 equals 0.
So I have x plus 6 equals 0. So notice we only have one root
Wait, why is it not the plus or minus?
because square root of 0 is 0. That's the only number where there's not
But
two
it's
numbers.
just negative 6?
Wait,
Yeah.
can you do like,
Well, because if you take each of these factors, ready? If you take each of these factors and solve them, set x plus 6 equal to 0, you get negative 6. Ready? Set the other x plus 6 equal to 0, you also get negative 6. The perfect square trinomial is the time when you only have one solution to your equation. This is the time, perfect square trinomials are when you only have one solution. Yep. Perfect square trinomials are the time when you have only one solution. It just touches the x-axis once, yeah?
So you don't really have to do all those steps. You'll just like done x plus 6 equals 0. Solve at the start.
Correct.
it's not x equals plus or minus,
No. So here, if I say plus or minus 0, it's just plus or minus 0. I'm still, if I subtract 0, it's the same thing as adding 0, and it does nothing.
Also, since you're square rooting it minus 6.
Huh?
Since you're putting the square root.
Yeah. Because I mean, when I square root 0, there's only one solution, 0. The only number multiplied by itself that's 0 is 0. Versus like 4. Oh, I could take negative 2 times negative 2 and get 4. And I can get positive 2 and positive 2 make 4. But literally the only number that is actually, if you square it and get 0, is 0 itself. It's a little confusing. 0 and infinity are always like whack. So square root of 1 can be negative 1 or positive 1. Negative 1 times negative 1 is 1. Yeah. All right, sit out, Dylan. Sit up, Dylan. You okay? Need water? Okay. All right, so I need to solve this. First thing I need to do is,
Square root.
well, I want to get n by itself. Notice we have to go through order of operation.
Divide by 3.
Divide by 3. So I have n squared equals 16. Now I square root both sides.
n equals plus minus 4.
Plus minus 4. Okay. Let's try out. Okay, let's try out e. Sorry, do you want me to go back? That was a little too fast. We okay with this one? Writing it down? Okay. So this is bringing me up to how, like, we're 2 steps away from completing the square, right? The completing the squares in quotation marks because it's a method of solving. So on this left side, I could factor it. This left side is a perfect square trinomial. How do I know this? Half of the middle is negative 3, and if I square it, it's equal to my c. So what this means is I could write the left side as x minus 3 times x minus 3. Also, I could write it as x minus 3 squared. That was a lot in one step.
So should we do that?
Sorry, a minus 3
Is that what
squared.
we should do?
Wait,
Yes, that's what I want you to do.
also do,
Let me do it 2 steps instead. So I could rewrite the left side as a minus 3 times a minus 3 equals 16. I could write that as a minus 3 squared equals 16. Right, Jesse, you want to pack up? So you're not late? And I'll screencast and it'll be uploaded to my Jag.
Okay, thank you.
Okay, cool. So expectation is you watch the screencast. If you have questions, you'll come to bonus, but only after you watch the screencast.
Alright.
Cool. Okay, so on this left side, I recognize it's a perfect square trinomial because if I half the middle number and then I square it, it will be the third one. So half the middle squared will be the third. That is a perfect square trinomial. Perfect square trinomials have 2 of the same factors. Right? The two factors are a minus 3, a minus 3. So instead of saying a minus 3 times a minus 3, I say a minus 3 squared. And then if I'm trying to get a by itself, I take the square root of both sides. A. Oh, sorry, it's a little blurry. So it'd be a minus 3 equals plus or minus 4.
You could do the same thing, just subtracting 16. Right?
If you subtract 16, you'll get the same a values, but it's not. It won't be a perfect square trinomial anymore. If you subtract 16 from just a moment. If you subtract 16 from both sides, it would change the problem into a squared minus 6a minus 7 equals 0, and then your 2 factors would be negative 7 and positive 1. But what we're trying to do, and the point of this exercise, is to show you how to complete the square. And on your test, there'll be a question where you must use completing the square. If you don't use it and you use the other way that you just said, you'd get 0 points. Okay.
How did you find that you used to?
So what adds to 6 multiplies to 9? Sorry, adds to negative 6
So the
multiplies 9.
16 doesn't have anything to do.
Right, I'm only doing the left side. Okay, so I have a minus 3 equals negative 4 and a minus 3 equals positive 4. And lastly, to solve for a, I add 3 on both sides. Just a moment. Add 3 to both sides. I get a equals 7 and a equals negative 1. Yeah, negative 4 plus 3 is negative 1. Yes. Yeah. Okay. What?
You didn't do that for like the first thing.
Which first one?
Like,
Where are you looking?
oh no.
B?
No.
Okay. Let's try out F. We still have
What does 7 have to do with it?
what?
What does plus or minus 7 have to do with
Plus or minus 7. Oh, up here? The square root of 49 is plus or minus 7. That's in part B.
it? No.
Where are you at?
I got a minus 3 equals plus or minus 4.
4,
and
yeah.
Add 3 to both sides.
Yeah. So 4
And I get
plus,
equals plus or minus 7.
you don't get plus or minus 7. Because if it says plus or minus 4, we broke it down into 2 parts. So we said a minus 3 equals
Oh, I
negative 4.
added 3 to plus or minus 4.
Right, which you can't do. You have to do, so you have to have positive 4 plus 3 and then negative 4 plus 3. Yeah. So plus or minus means you have to do both operations. You have to do the plus 4 and then you have to do the minus 4. All right, let's solve this one. M minus 5 squared equals 13. How would I solve this? Square root both sides. So we have m minus 5 equals plus or minus root 13. Is this a square? Is 13 a square? Can I simplify this? No, it actually is prime. 13 is a prime number. So to solve for m, I would say, okay, so I add 5 on both sides. I would say the solution is going to be m equals 5 plus or minus root 13. Because this takes into account both of my solutions. right? I'll have 5 plus root 13, and I'll have 5 minus root 13. Secretly, both of these options are in 5 plus or minus root 13. Awesome.
So if it wasn't like the root sign, it'd be like maybe 2 different ones. Right?
If it, then we actually could do 5 plus 13 and 5 minus 13, because we could actually compute those. Yeah. Technically, root 13 is going to be like 3.7 or something. So you could have like, 8.7 and 1.3 or something. But you can leave it in roots. That's fine. Leave it in radical. Because the point's not like, ooh, dealing with the radical. It's like, okay, how did you solve it? Do you have the right process, right? Did you go in the correct order? That's what I care about. Go up? Yeah. Okay, so did I like repeat my, I think I might have repeated. Okay, so here, solve. This should be a nice easy problem. Go ahead and solve it. What will the answer be?
X equals plus minus.
Plus or minus 10. Plus or minus 10. Okay. So this next one, first we must square root both sides. And then when we are doing the square root, we square root to get rid of the square. We introduce the square root. I have to do the plus or minus. So I have x minus 5 equals plus or minus 6. Meaning I'll have two solutions. I'll have x minus 5 equals positive 6. And I'll have x minus 5 equals negative 6. So you see our two solutions would be x equals 11 and x equals negative 1. Yes. Sure. Did I already do this exact one? No. Close. Okay. So for part C, we have x squared minus 12x plus 36 equals 25. Now I could subtract 25 from both sides and then factor and solve. But we're supposed to be using the square root property. So can I write the left side as something squared? Right? What I'm asking is C a perfect square trinomial? Is the left half of C a perfect square trinomial? If I take the middle and divide by 2, so negative 6, is negative 6 squared going to be 36?
Yes.
Yeah. So I can write this as x minus 6 times x minus 6, aka x minus 6 squared. So we already wrote this in the first example. I was trying to prepare you for setting it up.
X to the second.
What about x to the second?
Where does it go?
So I factored x squared minus 12x plus 36 into x minus 6 times x minus 6. So if you FOIL it, x squared minus 6x minus 6x, so you add them negative 12x plus 36. If you FOIL this back out, you get what we started. And then if I want to solve for x, what would the square root both sides? So I get x minus 6 equals plus or minus 5. So the x squared has nothing to do with determining if we have a perfect square trinomial. Perfect square trinomial means we have two of the exact same factors. And you can just look at an equation and know it's a perfect square trinomial if you take the b, the number in the middle, and divide by 2, and then square it, and that should be your c. That's how you can quickly tell if it's a perfect square trinomial. All right, so I'll have two solutions. So you do the b over 2, and whatever this number is, if you square the number, it should be your c. That's how you tell it's a perfect square trinomial. Then it's not perfect square trinomial. It won't be a special case.